Alright, let's look at the results involving inscribed angles. Alright, so there are three of them. So let's look at the first one. Alright, so you have A is the angle right here. And the measure of this arc is given to be x, and measure of this arc is given to be y. And we want to show that the measure of the angle A is 1/2 of x plus y. Alright, so let's do that. So the easiest way to look at it is probably add a segment right here. Alright, so we know that angle here is going to be 1/2 of, since this is an inscribed angle, and corresponding intercepted arc is x, so this is going to be 1/2 x right there. Right? Then if you view this inscribed angle here, and this is going to be 1/2 of the corresponding intercepted arc, so this is 1/2 y. Right? Then here, this is the exterior angle of this triangle. So the measure of the exterior angle, which is what we're looking for, is the sum of the measures of the opposite interior angles. And we know that one of them is 1/2 x plus the other one is 1/2 y. So that will give you the equation we wanted. Right? So that proves the first one. Second one, and now A is sitting in the exterior of the circle, and the measure of the arc here is y, and measure of the arc here is x. Right? Then we can kind of do the similar trick. We can just say something like you can just draw here. Right? Then you can see that corresponding to x, so this is inscribed angle here is 1/2 x. Right? Then you look at this inscribed angle corresponding to that, so this is going to be 1/2 y, so it's kind of small. Right? So again, we can use the exterior angle theorem. So angle A plus this angle is equal to that. So if you want to find the measure of the angle A, you can subtract 1/2 y from 1/2 x, which is exactly that. So that checks out. Alright, so third one, you have a tangent. So this guy is a tangent here, and this is the point of contact. Then if the measure is, let's see, of this arc right here is x, then measure of the angle A, which is this guy, is equal to 1/2 of that. Right, so let's see if we can prove it. Right, so first I'm going to just put a center of the circle. Right, then I'm going to complete a triangle here. Right, by doing that. Right, of course these are radii, so we know that they're congruent. So you have isosceles triangle. And also, since this is a tangent, so tangent is perpendicular to the radius at the point of contact. So this is 90 degrees there. Right? So using the, so this is a measure is x, so corresponding central angle has the same measure. So this is x as well. Right? And since you have isosceles triangle, so this angle sum is 180. So these two measures added up to be 180 minus x. Divide by 2. So this guy has the measure, right? 180 minus x divided by 2 is 90 minus 1/2 x, right? So this is 90 minus 1/2 x. But this is 90 degrees. So if you subtract 90 minus 1/2 x from 90, what's left here is just the 1/2 x, right? Which is what we're looking for, right? So this is basically 90 minus 90, quantity 90 minus 1/2 x. So that's going to be positive 1/2 x, right? We got that. Right, that's it. I hope that this was clear.